Hello guys, welcome to another video. Today we're going to work on topic 9 for AHL students. Multiple choice questions. So let's start working on the paper and see the solutions of the problem. Now number 1, it says, a car horn emits sound of frequency f. While the horn is sounding, the car moves in a straight line towards a stationary observer. The speed of the car is 0.110 v, where v is the speed of sound. What is the frequency of the sound of the horn heard by observer? So what do we have here? Here in this case we have a moving source and a stationary observer. And the source, it moves towards the observer. So here we have observer. Okay. So here we have one formula to work with Doppler's effect, and this one, it says the new frequency that the observer will hear, it's gonna be the velocity of the sound divided by the velocity of the sound minus the velocity of the source times the emitted frequency of the source. Okay, minus because the source, it goes towards the observer. So here what you have to do, you have to apply your numbers. So the velocity of the source is 0.1 of the velocity of the sound times f. So from here you see that all of those, they cancel out, and you have 1 over 0.9 times f. So of course the correct answer here is A. Number 2, the graph below shows the variation of the intensity of light with angle for the diffraction pattern produced when light is diffracted by a slit. According to the Rayleigh criterion, when the diffraction patterns of two slits are just resolved. So based on that, based on Rayleigh criterion, what you need to have is for the first minimum of the one pattern to align with the central maximum of the other pattern. So among all these choices, the only correct one is C. Only then these two are resolved. Okay, at this first time that the central maximum, it aligns with the first minimum. Number 3, it says that the bob of a pendulum has an initial displacement x0 to the right. The bob is released and allowed it to oscillate. The graph shows how the displacement varies with time. At which point is the velocity of the bob at maximum towards the right? So let's see what we have here. Here we have a pendulum that is displaced from its equilibrium position, so this is the equilibrium position, at x0. So this point here, it's x0 to the right. Let's call it plus x0. And this pendulum is going to oscillate between these two extreme positions. So we want the velocity to be maximum and towards the right. You have maximum velocity at the equilibrium position here. So here is your velocity maximum and towards to the right. So if it's initially is displaced at the x0, the pendulum, it's gonna move in this direction all the way to the left, and then it's gonna come back all the way to the right. So here at this point is when your velocity is maximum and towards to the right. So what do you need to do? You need to have 2 times the displacement to be 0. So you start from initial position, first time 0, you go to the other extreme point, and then you go back at 0 here at A. It's the first time that the velocity is maximum and to the right. Number 4, an object emitting a sound of frequency 100 Hz orbits in a horizontal circle at a rate of 2 revolutions per second. An observer standing a short distance away from the object is able to hear the sound. Which of the following describes the sound the observer is able to hear? A sound of constant frequency but varying in amplitude. This is incorrect. The amplitude, it will not vary. A sound of constant varying frequency. Well, this sounds right because the source, it moves towards the observer at once and then away from the observer, then again towards and away again. So this will be true. A sound with frequency of 50 Hz, well, this cannot be because it changes all the time. And a sound of frequency of 200 Hz. Of course, this is also cannot be because, as I said before, we don't have constant frequency. The frequency, it always varies. So of course here the correct answer is B. Now number 5. Green light is emitted by 2-point sources. The light passes through a narrow slit and is received by an observer. The images of the two sources just fail to be resolved. Which change allows for the images to be resolved? So what we want here is, if the images they cannot be resolved, we need to decrease the angle theta which the first minimum is observed. So based on this formula about resolution, well, if it was a circular aperture, we will have a 1.22 here number, but anyway, it doesn't really matter. This is what we have. Theta is proportional to lambda over b. B is the width slit. So what change we need to do? We need to reduce this angle theta. So how can we do it? The width is constant, it doesn't change. So the only way to do it is to decrease the wavelength. In order to do that, it doesn't matter if we place a circular aperture here, we don't have to move the source farther from the aperture. We need to change the wavelength, so we need to change the lights. So smaller wavelength, it has the violet light. So we need to use violet light. Number 15. A particle P executes simple harmonic motion about its equilibrium position y. The amplitude of the motion is xy. At which of the positions shown on the diagram is the acceleration of P equal to 0 and kinetic energy of P equal to 0? So first, let's see the acceleration. Acceleration, it needs to be 0 at the equilibrium position, because at this position in equilibrium you have no forces acting on the object. So it can be either A, either B at position Y. Now kinetic energy, in order to be 0, we need to have 0 velocity. 0 velocity we have at the extreme points. So if the amplitude is xy, so x, it means that is one of the extreme points. So it's gonna be x, so correct answer is A. Number 16. A particle executes simple harmonic motion with period t. Which sketch graph correctly shows how the total energy E of the particle varies with time t from 0 to t over 2. So be careful here. It asks for total energy of the particle. When we talk about total energy, we have to have constant energy. The energy doesn't change. It varies. Kinetic energy with potential energy, it varies, of course. But here we talk about the total energy. We don't have to look anything else apart of a straight line. Number 17. The diagram shows a train traveling in a straight line at constant speed v. As it approaches the platform of station, the whistle of the engine is emitting a sound of constant frequency. Which of the following is not true for the sound of the whistle heard by an observer on the platform? So what do we have here? We see like words like a sudden change, a sound of constant frequency, increasing frequency, decreasing frequency, and so on. So first of all, we need to know that even though the observer, it hears a different sound of the emitted sound of the source, the frequency, it's constant. It has a different value of the emitted one, but it's constant. So D and B, they are definitely true. Okay, a sound of constant frequency as the train approaches, and a sound of constant frequency as the train passes through the observer. Now, be careful, because we see when the train approaches, the frequency changes. Yes, the value is changing, the magnitude of the frequency, but it's always constant. The A, it says a sudden change in frequency of the sound as the train passes the observer. Yes, at the moment that it passes the observer, you have to have a change in frequency, because of course the frequency that you receive is changing, the value of the frequency, so you have to have a change. And number C, it's the correct one for us, that it's not true, that it says a sound of increasing frequency as the train approaches the observer and decreasing frequency after the train has passed the observer. This is not true. The frequency that you receive is always constant. Number 27. An ambulance emits a sound of frequency f as it travels along a straight road between stationary observers A and B. Which of the following shows how the frequency of the sound heard by each observer compares with F? So here we know that when the source, again we have a moving source, stationary observer. So when the source, it moves towards the observer, the frequency that you hear is bigger than the emitted one. When it moves away from the observer, the frequency that you hear is smaller than the emitted one. So observer A here on the left, either C, either D, less than the emitted frequency F. Observer B on the right, greater and greater than F. Of course, correct answer here is C. Number 28. The density distribution of monochromatic light passing through a narrow slit and then incident on a screen is shown below. So we have a narrow slit, a single slit diffraction pattern. When the slit width is reduced, which diagram shows the new density distribution? Diagrams are drawn to the same scale as the original. So what we have here? We have the single slit to be narrower than before. So the density, your new density, it needs to be smaller than the first intensity because, of course, less light it passes right now from the slit. So we need to see here when the density is smaller. I'm going to show you here the other options. Okay, so it cannot be D or A. Now, apart of that, based on this formula, we are also looking for other patterns here. For example, the width slit, it's become smaller. So that means the angle, it needs to be bigger because the wavelength, of course, is constant. The same light passes through. So also you need to have a different angle here, theta. So as you can see from the first one. So, of course, it cannot be C, it has the same. The only correct answer is B. And number 13, it says that a parallel beam of monochromatic light of wavelength L passes through a slit of width B and forms a diffraction pattern on a screen far from the slit. The angle at which the first diffraction minimum is formed is theta. Which of the following changes in lambda and B carried out separately will increase the value of theta? So what we need to do, we need to see again this formula for the angle theta, and separately, what we have to do in order to increase theta, we need to increase lambda. And from the other hand, in order to increase theta, we need to decrease B, the width of the slit. So, of course, here it's increase the wavelength and decrease the width. So, the correct answer is number D. Okay, so that's all for today, guys. Study hard and good luck.